Okay, chapter 4-5 continued is the horizontal shifts. Now I broke this down into two separate sections for you guys because it's important for you guys to understand the amplitude, what that does. It's important for you to understand the B value, which changes the period. And then it's important for you to understand the C value, which shifts it up and down. The things that throw a big curveball to you guys is whenever I start moving where we're going to start the sine graph and where we're going to end the sine graph for a period. Okay? And what this is known as is a horizontal shift. A horizontal shift literally picks up the entire graph and moves it without changing the look of it left or right, whichever direction. Okay? Do we understand that? So this is what your graph looks like. You're not going to see this in the textbook. You're not going to see y equals a times sine bx plus minus d plus or minus d. This is kind of a Yoderism here. Okay? And I have the Yoderism here because it makes sense for you guys to understand what each letter does to the equation. Does that make sense? Amp. A is your amp. It changes the height and the depth of the graph from the level position. The level position is in the middle of the graph. Do we understand that? Okay? It's zeros on the unit circle. The B, it changes the period of the graph. In other words, the typical period of a sine and cosine function is how many units? 2 pi units. It's one revolution around the unit circle. Do we all understand that? Now, the C moves the entire graph up or down, and the D moves the entire graph left or right. This changes the starting point and the ending point of a graph. Typically, we start at 0, and then we end at 2 pi, correct? Typically, we start at 0, and we end at 2 pi. So if we're looking at that, the starting point is equal to 0, which means you're going to take the jump that's in the parentheses, the bx plus or minus d, and you're going to set that equal to 0. You're going to solve for x. This is your new starting point. Now, the difference between the two worksheets that I've given you is the first worksheet, your starting point was always what value? 0. And your ending point would have been? No. Your ending point would have been your new period that you calculated, the b value, correct? So your starting point was always 0, and your ending point was always your period value. Do we always understand that? Do we get that? Now, with tonight's, your starting point is not at 0 if your b value, if your d value has changed it. B changes the period, D changes your shift, where you're starting and ending. Okay? So my d value, if I have one, it'll be in parentheses. Okay? That's going to change your starting point. Which means if I've changed my starting point, I've automatically done what? I've automatically changed my ending point. So instead of my ending point being at my period value, it's now going to be shifted over left or right d units. Okay? How do I find that? Well, typically my ending point was at 2 pi. So to find my new ending point, I take the jump that's in the parentheses, the bx plus or minus d, set that equal to 2 pi, solve for x, and now we have our new ending point. Okay? Now we have our new end point. Do we all understand that? Whenever I say starting point and ending point, what I'm talking about is one revolution for that graph. Understanding that the sine and the cosine curve are continuous forever and ever and ever, right? I'm taking one snippet of the graph. Do we all understand that, yay or nay? Okay. Now, with that said, what we have here is y is equal to 2 times the cosine of x plus pi over 3 plus 5. So what I need you to understand are the players in this game. Okay? What's the first thing you need to get in here? The 2. The amp is your 2. Do we understand that? What does the amp do again? It makes it up or down. It's the height of your graph or the depth of your graph from where? The level position. So whenever it's level, in other words, if I'm building my house, okay, and my maximum value is going to be 2 units. My minimum value is going to be 2 units from level. Level can be at negative 10. Level can be at 25. Level can be at 5,332. Do we understand that? From wherever level is at, I'm going to go up 2 units from that, and I'm going to get a relative max. What's a relative max mean? A relative max means it's a maximum point given a unit of measurement. So within this unit of measurement, I have a max here. That doesn't mean throughout the entire graph that's my only max, right? But in this unit of measurement, I have a relative max. Now, because the sine and cosine curves are symmetrical, the maxes are exactly the same if they're across the board. Do we all understand that? The min would be exactly the same if they're across the board.
What was a relative max?
A relative max is going to be a maximum according to a unit of measurement within wherever you're at, like a domain, okay? It's going to be a maximum within a unit of measurement. Okay, now, what's my B value? And I do want to write this as A is equal to my amp, which is equal to 2. What's my B value, which changes my period? And that's the value attached to the x. Do we all understand that? What should this tell you then, folks? You should be very thankful that your B value is 1. Because what does that mean? Has my period changed then? No. So my period is still going to be what value? It's going to be my 2 pi divided by absolute value of b, which is going to be 2 pi divided by 1, which is just still going to be 2 pi. Which is a very helpful thing to understand, because that means that my entire graph is 1 revolution around the circle. I'm not changing my period. In other words, I'm not sleeping, where my heart rate is being stretched out like a slinky, and it's taking a long time for my cycle. Does that make sense? And I'm not hyper and exercising and going crazy, so my heart rhythm is going nuts. Does that make sense? Yes or no? It's a standard typical B value. Okay, so my period is 2 pi. Now what's my C? It moves it up or down, right? Okay, my B value is 5, which means I'm taking the whole graph and I'm doing what to it? I'm moving this whole thing up 5 units. Do we understand that, yay or nay?
Yeah.
Okay, now what does that D do to it? What does D do to the graph?
Move it left or right.
Moves it left or right, correct? Now, in this case, my D value is pi over 3. So what am I actually doing? It's plus pi over 3, so which direction am I going? Going to the left, pi over 3 units. Now I want you to think about that for a moment. If typically I'm starting at 0, okay, I am the y-axis, okay? Over here, I have the positive x-axis. Over here, I have the negative x-axis. Do we understand that? If I typically start at 0, dead center, okay, and now moving to the left, pi over 3 units, what is this value over here?
Negative.
Negative pi over 3 units. Do we understand that? Okay? So what you're going to be doing is you're going to be adding an interval to a negative number. Because when we graph sine and cosine, we're graphing them on the x-axis, which means we have positive and negative numbers. Do we understand that? So to find where my starting and ending points are, the first thing I have to do is I have to set the jump equal the jump, which is bx plus or minus d, equal to 0. So what is the jump in this case?
Plus or minus.
So it's going to be x plus pi over 3. Notice I put plus or minus d because it could be adding d units or it could be subtracting d units. In this case, what are we doing? We're adding d units. So I'm going to set this thing equal to 0. And now what do I need to do? I need to solve for x by subtracting pi over 3 units. So x is starting at negative pi over 3. That's my first x value that I'm going to use. And that makes sense because we already talked about the fact that it's being shifted to the left pi over 3 units. Which if I'm starting at 0, the left pi over 3 units means I'm going negative pi over 3.
Did you skip the interval?
I did. We'll go back. Okay? Now, do you see where I'm starting at? I'm starting at negative pi over 3. Now what do I need to calculate? I need to calculate my endpoint. Well, my endpoint says I'm taking bx plus or minus d and setting that equal to 2 pi. Why 2 pi? Because that is the typical period, okay? It has nothing to do with what our period is in this problem. It has everything to do with the normal, typical ending point for sine and cosine. Do we understand that? Okay, so now this chunk is going to be the x plus the pi over 3 is equal to 2 pi. And how do I solve this thing for x? I'm going to subtract pi over 3 units. So if I'm subtracting pi over 3 units, this right here is going to turn into 6 pi over 3. So what is 6 pi over 3 minus pi over 3?
5 pi over 3.
5 pi over 3. Now, here's what you need to understand about the starting and ending point. If I take my ending point and subtract off my starting point, it should equal my new period. Whenever I say my new period, what I mean is the period that you calculated with the 2 pi divided by the absolute value of b. If your period that you calculated was let's say 3 pi over 2 units, when you take your ending point, subtract off your starting point, you should have that period. Okay? So let's try this and prove that it equals that. So if I take 5 pi over 3 and subtract off my starting point, which is negative pi over 3, minus a negative turns into a positive, and that gives me 6 pi over 3, which reduces down to 2 pi. Is that my period in this problem?
Yes.
It is, which means I know that my period is correct. I have done my math correct. Do we understand that? Okay, now, there's a couple more things we need to do before we can actually graph this thing. We found A, B, C, and D. We found our starting point and our ending point. What we have not found are 4 more critical pieces of information for us to do the rest of this graph. Another critical is our interval. Another one would be max, level, and min. So those 4 pieces of information are very critical for us to be able to graph the rest of this thing without actually having to do a whole bunch of calculation work. True statement? So with that said, we need to find our interval. So how did we find our interval? It's our period divided by 4. So our period was 2 pi, and then when we divide that by 4, please reduce right. Because Ashley was here yesterday and asked, I don't understand what I'm doing wrong. It's because she wasn't reducing her fractions correctly. So reduce correctly. And this is going to be pi over 2 increments. And that should make complete sense to you. And why should it make complete sense if this interval is pi over 2 units? Because the whole point of graphing these is so that you land on your axes, correct? Your axes are the x and the y axis. Now, what angles lie on the x and the y axis?
3 pi, 2
Pi over 2, pi, and 3 pi over 2, which means they are all cut into quadrants, which means they're 90-degree quadrants, right? Agree? Now, if my interval, or I should say if my period is 2 pi, if I want to have equal increments, that means it has to be pi over 2. Do we all understand that? So now we found our interval, which is excellent. Now I need to find my level. Do you remember from yesterday how we found our level?
It's C.
0 plus or minus C. Because 0 is where the sine graph is always starting at. Its level is always at 0. So what was my C value here? 5. So my new level is going to be at 5. Do we understand that? Now my max. Does anybody remember the formula for the max? The level plus the amplitude. So that's going to be 5 plus 2, which equals 7, is my new max. And my minimum is going to be your level minus your amp, which is going to be your 5 minus 2, which is going to be your 3. Do we understand that? Now, my question to you is, am I graphing sine or cosine here?
Cosine.
I'm graphing cosine. So the next thing to be able to use our nice little formulas that we have been using, or our patterns that we're using, is we need to get the picture of sine in our head. Or not sine, but cosine in our head. What does cosine look like? The graph of cosine looks like this: max, level, max. Right? Max, level, min, level, max. Okay, we have a nice little view with the graph of cosine, correct? So with that said, now we have all of our information. We know what we're looking at, so we can go to the last part, which is to fill out our lovely little XY table. So we come over here. And this was y is equal to 2 times the cosine of x plus pi over 3 minus plus 5. Sorry. Where am I starting at?
0.
No, I am not. My starting point is going to be negative pi over 3. Now, to make this very easy on yourselves, because you guys don't do well with fractions, no offense. I don't mean to offend anybody here at all, but I'm just being straight up honest with you. Well, try not to be too offended. Okay, what I want you to do is simply I need a new document. I'm going to do a calculator, and it's going to be so much easier if you do it like this, okay? The fractions that you're adding together every time are going to be what? Right now we have -1 divided by 3. Do I care about the pies? No, the pies are not important. And then I'm going to add to that what?
1/2.
1/2, and hit enter. So what is that first one that we're going to add? First increment. It's going to be pi over 6. So this is going to be pi over 6. Now go to the next one. I'm going to take that answer. I don't want an ink layer. Don't do that to me. Do not do that to me. I'm going to get that. This is going to be pi over 6. So now we're going to go back over here, and what are we going to do? We're going to add to that 1 divided by 2 and hit enter. And what's the next one going to be? 2 pi over 3. Then we're going to go to the next one and do what? Add 1/2. And that's going to be 7 pi over 6. And then we're going to come back over here and add one more to it, which is going to be 1 divided by 2. And that's going to be 5 pi over 3. Now my question to you is that where my ending point was supposed to be? It was. Do you see how we use the calculator to help us adding all these fractions? My goal is not to make your life miserable, but to make you help you with the calculator to be able to do all this stuff. Can you all add these fractions? Yes. You have proven to me that you know how to get a common denominator and you can do all that jazz. Now the next thing you need to understand is what does the graph look like? Well, we already talked about this, that it looks like a what? A U. So we're looking for our max, our level, our mid, our level, and our max. So what is the maximum value?
7.
What's our level? 5. What's our mid?
3.
What's our level? And what's our max? Do we all understand what the graph is going to look like? Now, what I want you to do is we're going to add another page, then you're going to graph this. So how would I graph something that looks like this? Well, you have to leave room on the left-hand side now. You have to leave room on the left-hand side because you're starting on the left-hand side. So this is going to be your negative pi over 3. Over here is going to be what?
5 or 6.
Over here is going to be what?
2 pi over 3.
Over here?
7/6.
And lastly?
5 over 3.
Do you see how I have them all in equal intervals? Except for the first one. There's one right next to it. A much bigger gap there. Okay, do we all see that, yes or no? So now at this point, now you're going to add your values. There's 7, here's your 3, and there's your 5. Okay? And I'm actually going to move those out. Oh. Okay? Now, at pi over 3, we're going to have max, and then we're going to have a level, and then we're going to have a min, and then we're going to have a level, and then we're going to have a max. Do we see the graph? Now, how do you get your calculator to show the same view that you are drawing on your graph paper? I'm going to add a new page. I'm going to graphs page, and I'm going to type this in. That's going to be, what was it, 2 cosine, parentheses,
Parentheses, plus 5.
Okay, there's my trig function. I'm going to go to menu, window, window settings, and I want it to start at negative pi divided by 3. I want it to end at 5 pi divided by 3. I want it to go by increments of what?
2, 2.
Pi divided by 2. And what do you think I want my y minimum to be?
2.
You can go one less, which is going to be 2. If you're really anal and you like to see the x-axis down there, you can make it so it's -1 so you can see that x-axis, whatever makes you happy. Okay, your y max is 7, so I need to go one more higher, so 8. And I'm going to go by increments of 1 here, just because it's nicer, I think. There's our lovely little graph. Okay, do we see that? Now, if you want to check your XY table, which you always should be, do you hear what I'm saying? These two things that I'm doing in the calculator, you should check for every one of your problems. I'm going to hit Control-T for my table. I'm going to come over here and I'm going to hit Menu, Table, Edit Table Settings. I'm starting at negative pi divided by 3. And my step's going to be pi divided by 2. Do we see that? And hit OK. Go to Menu, Table, Table Settings. And you're starting at negative pi over 3, and you're going by increments of pi over 2. And you can check your lovely little XY table to make sure that you are accurate. Now, generally speaking, what you guys have a tendency to do is you check to make sure that your periods are correct, but you do not check to make sure that when you graphed it, that you have your max level min correct. Now, if it's flipped, if it's multiplied by a negative somewhere in there, and you forget to reflect it, your graph is going to be wrong. Do we understand that? So in cases like this, you need to be very, very, very cautious and make sure that you're getting the correct max level min values. Any questions? Do we understand this? Now, I do want you to look at problem number 1 on that worksheet. If I'm looking at this worksheet here, does this one have a horizontal shift? No, there's no parentheses there, is there? Okay, we have an amp, we have a period change, and we also have a vertical move, correct? A vertical shift. Number 5, or number 2, do I have a horizontal shift there? I do have a horizontal shift. So I have an amp change, I have a period change, I have a horizontal and vertical shift change. Do we understand that? We did number 3. Number 4, do I have all of them there? Do I have a period change? I do not have a period change, do I? I have an A, I have a D, and I have a C. My B value is 1, so my period is still going to be 2 pi. Do we understand that? Okay? Look at number 5 here. Do I have all of them? I do not have a vertical shift, which means my level will be where? 0, which means my max will be 4, and my min will be -4. Now tell me, what's going on with that negative amp? The graph has been reflected, which means what? Instead of sign looking like level, max, level, min, level, now I'm going to have it reflected to look at level, min, level, max, level. Does that make sense? Okay? And then the last one. Do I have a vertical shift? No, but do I have everything else? Are there any questions over this? Does it make sense today? Number 5 being reflected is, since it's reflected, you're going to have a level, then you're going to go down to a min, then you're going to go back up to a level, you're going to go back to a max, and down to a level again. Okay? Any questions over today? Danny, does this make sense of what we were doing? Okay, I'll help you in a second. All right, I'm done.